Hello everyone, I hope everybody is fine and ready to learn more about trigonometry. In this lecture, I have the intention of giving you more and more examples about the applications of trigonometric identities. First, we're going to prove a trig identity. The left-hand side is 1 minus cos of 8x over 8, and we have to prove that it's equal to sine squared of 2x, cos squared of 2x on the right-hand side. So I start with the left-hand side. 1 minus cos of 8x over 8. And instead of cosine of 8x, I'm going to consider 8x to play the role of double angle for me, and then the single angle would be 4x. And we have this identity. It says cos of 2 alpha is 1 minus 2 sine squared of alpha. So what plays the role of alpha for me is 4x, and what plays the role of 2 alpha is actually 8x. So this is just like cos of 2 alpha. So I can write 1 minus 2 sine squared of alpha, where alpha is half of 8x, that is 4x. So 1 minus 2 sine squared of 4x all over 8 is what I get. When you simplify, 1 minus 1 cancel out each other, so you end up with 2 over 8 sine squared of 4x, which is, of course, sine squared of 4x all divided by 4, because 2 over 8 is nothing but 1/4. But then sine of 4x is just like sine of 2 alpha, where alpha is 2x. So I'm going to use double angle formula for sine this time. So I go 1 over 4, and then I have to square sine of 4x. But sine of 4x would be 2 times sine of 2x cos of 2x. And now we need to square this. So 2 squared is 4. So we end up 4 over 4 sine squared of 2x cos squared of 2x. And 4 over 4 is 1. Therefore, sine squared of 2x cos squared of 2x is what we derive, which is the right-hand side. So we start with the left side, and we prove that left side is equal to the right side by using a few trig identities that we have studied in the past. I used double angle formula for cosine here, and I used double angle formula for sine actually. And after simplifying, we get the final answer. Next one is another application in physics. Many of you are taking physics as I speak. Maybe that's the other subject you are taking. And this is a pendulum. Maybe you have studied the periodic motion in physics, and you have studied how to calculate the period and frequency of a swinging pendulum. Anyhow, we have a pendulum whose length is 10 centimeters, and we just slightly move it to the right so that it makes an angle of theta with the vertical, and we want to find the height of the height. Of course, let me show you this diagram. Let me show you. When you move this pendulum to the right a little bit, then if you draw a horizontal line from where the bob of the pendulum is located, then the height of that with the lowest point, which is happening at the equilibrium of equilibrium position of the pendulum, that height, which is like this distance, basically, we need to prove that that distance is equal to 20 times sine squared of half angle. That's what we need to prove, basically. So the vertical height, vertical displacement of the pendulum relative to its lowest point, which is the point where the pendulum is passing through its equilibrium status. So anyhow, how can we find this height? That is the question here. And this height that we are finding, we have to show that it's actually equal to 20 times sine squared of half angle, and half angle would be half of this angle. If this angle is like 40 degrees, half of it would be 20 degrees. So it will be 20 times sine squared of 20 degrees, basically. That's what we have to show. So what we're going to do here, we're going to say, okay, this total length is actually 10 centimeters, okay? And if we knew what this height is from here to here, if we knew what that height was, I would do a simple subtraction and I would find actually this bottom height. So in order to find out what is this length, I'm going to say we have a right angle triangle here. If you think about it, hypotenuse is 10, and we're trying to find this adjacent side. So you know SOHCAHTOA, so if you multiply the hypotenuse by the cosine of the angle, that will be 10 times cosine of theta. And if you multiply hypotenuse by the sine of the angle, that would be 10 times sine of theta, which would represent the opposite side of this angle theta. So knowing this, we would say the total length is actually L. And if you subtract the higher part, which is L cos theta, because generally speaking, the length of the pendulum is L units. That's the hypotenuse. So it will be L times sine theta in general. But if the length is 10 centimeters, obviously you substitute for L. That's not a big deal. So this is L times cosine of theta in general, if the length is L units. So L is the total length minus the upper part, which we said it's L cos theta. That will be actually H, which is the lower height. And if you factor L out, you get 1 minus cos theta. And instead of cosine of theta, we can use trig identities, double angle formula for cosine. But which one of these three? I would say we can use this third one. So 1 minus 2 sine squared of half angle. That is what I plug in for cos theta. And then we have 1 minus 1 cancels. So we get 2 times sine squared of half angle. And then the answer would become 2L sine squared of half angle. So H would become this expression. We found a formula for H, the vertical displacement of the bob of the pendulum. Now, because L is equal to 10 centimeters in this particular exercise, so we can substitute 10 for L. So this becomes H equals 2 times 10, which is, let me show the work, sine squared of theta over 2. So 2 times 10 is 20, sine squared of theta over 2. That becomes the height, or H here. And that's what we wanted to prove. And you see that here, I used the double angle formula for cosine in this physics question. This one is another question, and it's about a building and a flagpole on top of the building. Of course, the diagram is not drawn to scale. It says a flagpole, which is here, 15 feet high, is situated on top of a building 10 feet high. At a point on the ground, X feet from the base of the building, the flagpole and the building subtend equal angles. Find the value of X. So subtend by the same angle, it means that these two angles are both equal, so I call them alpha. And we want to find the horizontal distance between the point on the ground up to the building itself. That horizontal distance, X feet, we want to calculate that. Given the height of the building, which is 10 feet, given the height of the flagpole, which is 15 feet, as I said, the diagram is not drawn to scale, it's not important, we have the dimensions, and that is what we want to find. We want to find basically this horizontal distance X. For this purpose, I draw a geometric diagram, as you see, and I'm going to say there are two right angle triangles here. One of them is the big one, triangle ABC, and if I write the tangent ratio over there, if I write tangent of that big angle, which is actually tangent of 2 alpha, okay, that would be equal to the opposite over adjacent. Opposite side would be 10 plus 15, which is 25, over adjacent side, which is X. So I have one equation, two unknowns, nobody can solve that. Tangent of 2 alpha, we don't know what alpha is, equals 25 over X, we don't know what x is. So this is one equation. I need a second equation. Therefore, after writing the tangent ratio in the big triangle ABC, I'm going to write the tangent ratio in the smaller right triangle ABD. So this time I'm going to say tangent of 1 alpha is the opposite side, which is BD, over adjacent, which is AB. Opposite side BD is the height of the building, which is 10 over x clearly. So I got two equations. Tan of alpha is 10 over x. Tan of 2 alpha is 25 over x. Now we need to find x basically from these two equations. How can we do this? Well, tangent of 2 alpha. It reminds me of tangent of double angle. And we have the identity, we have the formula from before. So that is 2 times tan of alpha over 1 minus tan squared of alpha, right there, which is equal to 25 over x. But the thing is that tan alpha, tangent of alpha, is 10 over x. We already found it from the other right angle triangle. In triangle ABD, we figured out that tan alpha is 10 over x. So why don't we just substitute here? And this way we get rid of tangent of alpha. We're eliminating one of the unknowns, that is alpha. And our equation would be only in terms of x. We can solve for x. So that's the plan. So 2 times 10 over x over 1 minus 100 over x squared, because I squared that. That is equal to 25 over x. Okay, so I need some room to solve this equation for x. Then we will be completely done. So let's see how we can do this. This is 20. So 20 over x times x, if I cross multiply, 20 over x times x will be just 20. I'm going to write it here. And then 25 times this expression would be 25 minus 2,500 over x squared. Okay, this is what we end up with, I believe, because 10 over x times 2 is 20 over x. And 20 over x times x would be just 20, because x and x cancel out each other. We are actually cross multiplying. And then 25 times 1 minus 100 over x squared will be 25 minus 2500 over x squared, clearly. And if you rearrange the terms, you get 2500 over x squared equals 25 minus 20, which is 5. So from here, 5x squared is 2500. I'm doing cross multiplication again. And from here, x squared would be actually 500. X squared is 500. You take the square root of both sides. So x would be plus minus 10 root 5, because 500 is 5 times 100, and square root of 100 is 10. So it will be 10 root 5. But when we say plus minus, considering the fact that x is a distance and this distance cannot be negative, so the negative answer would be inadmissible. Therefore, x should equal to 10 root 5. And the unit of measurement is, of course, feet, right? So f. So the negative answer is inadmissible. Okay? I didn't have room. That's why I wrote it there. But I hope, you are taking notes and you understand. Final answer, the horizontal distance from the building is 10 root 5 feet. That's the exact value. If you want to find the approximate answer, correct to 1 decimal place or something, you can use the calculator definitely. And because it's a word problem, so you better actually write the final closing statement or a paraphrase, as we have always been doing traditionally in word problems. So you're going to say, for example, the horizontal distance between the point on the ground, or between the person and the building, is like 10 root 5 feet, for example. Okay. All right. So one question from physics, applications of trig identities. You saw that. Another question again from geometry, applications of trig identities. That was the idea, to show you how we apply trig identities in solving like word problems. And the first question was just a simple question about proving a trig identity. All right, I think you have seen enough questions about trig identities. So the next lectures will be about trigonometric equations. Thank you for your attention, and keep practicing as much as you can.